Okay, so in this video, this is going to also be our other video for geometry about linear functions. Um, and there's probably going to be quite a few because this isn't the first lesson about it. But anyway, going off on a tangent again. So pretty much we're looking at this EQ, and that is not the color that I want to write in. Um, we are going to be talking about two different ways that we can graph linear equations or linear functions. You're going to hear me refer to it in either way. One way is using the slope and y-intercept, right? Meaning we need to be in f of x equals mx plus b. We need to be in slope-intercept form, right? That's one way we're going to do it. Another way is going to be using a t-chart or a input-output table, right, to plot points. Okay, and they both have their uses, right? So here we've got four examples, and I'm going to go through these pretty quickly. Um, and actually, I'm probably going to do number one and three only, just to keep this video short. So this first example, I'm going to go ahead and make what we call a t-chart or an input-output table. Okay, so my input is my x value. My output is my y value because y depends on x, right? So let's say I start at, I don't know, negative 5. Okay, x equals negative 5. When x is negative 5, negative 2 times negative 5 plus 1, that's going to give me positive 10 plus 1 is 11. So when x is negative 5, y is positive 11 way up here. So that's 1 point, right? Then I'm going to just keep going. So I'm going to skip around a little bit. I'm going to go by twos because why not? So now let's try negative 3. So when x is negative 3, when x is negative 3, I literally substitute in for x with a negative 3, right? Multiply it out. So negative 2 times negative 3 is positive 6. Positive 6 plus 1. Positive 6 plus 1 is going to give me a 7. Okay, so at negative 3, right, we know we're going to be at positive 7, right? And we see here, so negative 5 by positive 11, negative 3 by positive 7, right? And let's go by two more, right? And actually, let's skip a little bit further. Let's go ahead and look at positive 3 now. Okay, so let's say we do positive 3. So negative 2 times positive 3 now, plus 1. Negative 2 times positive 3 is going to give me negative 6. Negative 6 plus 1 is going to give me negative 5. So at positive 3, we are at negative 5. Okay, so positive 3 by negative 5. And the cool thing about this is now I can simply, if I have a ruler, I can simply just connect these three dots. I don't even need that many. Um, Really, you only need two. I can connect these three dots with a line, assuming that I did this right. And I didn't because I'm stupid and I put 3 by 7 at 3 by 8. So let's move that down where it's supposed to be. If you're watching this video, hopefully you caught that and, got a good laugh. But anyway, yeah. And if you can't tell by my voice, I'm pretty sick right now making this video, so I'm going to use that as an excuse. But anyway, we see this green or this blue line rather uh, graphs out our equation perfectly. And this blue line here represents this actual function here, y equals negative 2x plus 1. And we did it using a t-chart, right? So now we're going to look at an alternative method, right, using number 3 here. Okay, so right now we're in slope-intercept form. Y equals mx plus b. M is 1/3, right? That's my slope, meaning delta y is equal to 1, and delta x is equal to 3. right? And B is my y-intercept. Okay, so what that means for me is I'm going to start at my y-intercept of y equals -4. 0 by -4. Okay? And then we're going to see how easy this is. So I'm going to count using rise over run, right? Delta y is +1, right? And delta x is +3. Okay, so my next point is right here. And we know that we can just connect these two. And I'll tell you what, if we just keep going, so +1, +3, here we are again, and +1, +3, here we are again, and we just keep on going and going and going. And we see that we have a nice, cute line forming, right? And you're probably wondering, well, duh, how do we go back the other way? Well, another way to say +1 over +3, we could say -1 over -3. This would be a double negative, right? And it still takes us in the same direction. So let me show you what I mean. -1, -3. That puts me right here in my next spot. -1, -3 puts me there again. -1, -3, right? And we see we're still forming that same line. It has the exact same rate of increase. Okay, so now I'm just going to erase, right? And just to prove a point, let's go ahead and use our t-chart here, except we're going to use it for our other function. So let's just plug in an arbitrary point. So one point obviously is 0 by -4. So let's make sure that that even works. And of course, you don't have to do this. Just two alternative methods of doing the same thing, right? But you need to know both. But when x is 0, y should be -4, right? Because we have that point right over here. Okay, so 1/3 times 0 is 0. 0 minus 4 is, in fact, -4. Hey, it works. Okay, well, let's try it with another arbitrary point that we see here on the graph. Let's try it here on this side. We see 6 by -2. Okay, and I'm, of course, referencing this point here. So when x is 6, we should get y is -2. So 1/3 times 6 is going to be +2. 2 minus 4 is, in fact, -2. So again, we see that it works. Okay, so those are two alternate methods in which you can graph out a linear function. Sometimes it's convenient to use just a purely geometric method like what we did here in pink, where we just, get started with the y-intercept and count using whatever our slope is. Sometimes it's more convenient to use what we did here in green, where we just make a t-chart, right? It all just depends. And it also depends on what's easier for you personally, okay? So that does it for this video. Like always, if you have any questions, shoot me an email or come and see me. Goodbye.